Satyabama Institute of Science and Technology. Your career begins here at Satyabama Institute of Science and Technology, a deemed to be university, a nationally recognized and globally acclaimed destination to accomplish your academic aspirations. The Colonel Dr. JPR Research Park, along with the International Research Center, houses advanced research facilities that have 13 centers of excellence, 10 plus technology transfers, 100 plus patents, 10,000 plus reputed publications. The Satyabama Center for Advanced Studies is a state-of-the-art facility built with the aim to cater to the futuristic aspirations of our students with the aid of a metaverse studio, drone labs, makers space, media center, advanced characterization facilities, ICT-enabled classrooms, and supercomputing laboratories. The engineering departments are equipped with sophisticated infrastructure, fulfilling the academic and hands-on requirements of our students. The architecture department is furnished with sophisticated design studios and spacious drawing halls, all of which support the learning process of our postmodern generation architects. The Satyabama General Hospital, along with the School of Dental, Nursing, Pharmacy and Physiotherapy, have advanced clinical facilities. The monumental Central Library houses a diverse collection of books, periodicals and journals. Additionally, it also has an open-air theatre with a seating capacity of 1,000. The Management, Arts, Science, Law and Hotel Management departments comprise of all the necessary and required facilities, creating the perfect ambience for our far-sighted students and catering to their skill set needs with the end goal of equipping them to live their dream. Our chain of laboratories with practical exposure equips our students to build a successful career. Our institution has a team of dynamic and outstanding teachers who are ever reachable to our enthusiastic students, promoting the spaces to learn and places to grow. Greenery around the campus greets and accommodates our students, who are the backbone of a developed nation, edging them on to achieve the summits of their success. Satyabama Institute of Science and Technology.
So good afternoon, everyone. A very warm welcome to all the participants to another session of Ocean Research Knowledge Series 2026, organized by our Center for Ocean Research and NFCMR with the support of Ministry of Earth Science, Government of India. Today's expert lecture is on anti-fouling strategies from traditional coatings to next generation solutions. We are very pleased to have with us Ms. Anu, Scientific Assistant, Center for Ocean Research, Satyabama Institute of Science and Technology, who will be delivering today's lecture. Ma'am, a very warm welcome to you, and I now invite you to take over the session to you, ma'am. Thank you, ma'am.
Thank you. Thank you, Mr. Tawfiq, for a warm welcome. Good afternoon, everyone. I will share the screen now. Is the screen visible?
Yes, ma'am.
Yes, thank you so much. So, good afternoon, everyone. Myself, Anu, I'm working as a scientific assistant in Center for Ocean Research, Satyabama Institute of Science and Technology. Today, I'm presenting my topic, anti-fouling strategies from traditional coatings to next generation solutions. So, coming on to what is biofouling. So, biofouling refers to an undesirable accumulations of biotic deposit on a surface which is immersed in water for a long period of time. So biofouling will not happen in a single day or in 2 to 3 days. It will occur like a series forms. So initially, when a substrate is immersed in the water for a long period of time, there will be the first step of EPS secretions and proteins through which the bacterial will multiply and it will come and attach. And after the bacterial attachment, there will be the diatom attachment, after which the macroalgals will come and attach, and followed by macrofoulers like barnacles, oysters, mussels will come and attach. So it will happen as a series of reactions as time goes on. So in this diagram, you can see the first thing is your conditional biofilm and biofilm formation through the bacterial thing. And then the third one is your diatoms or larva microalgal spores. And after is a major problem in marine industries. Majorly, it happens in maritime industries, which affects the ship hull. So in the first image, you can see that the ship hull is affected by macrofoulers, right? And in the second right side image, you can see that the bridges which are immersed in water, it is fully fouled by the fouling organisms. And the third image is like a sensors or instruments which is used to detect the temperatures and pH and other things. So that is also followed by fouling organisms. And the fourth image is your aquaculture cage nets. So which we'll be using for fish aquaculture, right? So that is also followed by mussels and barnacles. So moving on to the disadvantages of the fouling. So the major problem due to this fouling is an like increased drag force. So continuous attachment of this foulers will increase the roughness of the surface, which increases the dragness of the ship during sailing. And the second one is your higher fuel consumption. Since the drag is very high, obviously the ship will not move easily, so it requires higher fuel consumptions. And the third thing is your structural damage. So continuous fouling will cause us a corrosion, which in turn will damage all the materials or coatings which is present above the ships. And fourth one is your maintenance and cleaning cost. So if this is happening in a repeated stage, like we have to continuously move the ship for dry docking and cleaning purpose, where more manpower and equipments will be used for cleaning things. So it is a maintenance and cleaning cost will be very, very high. And moving on to the fifth point, it is introduction of invasive species. So when the ship is sailing from one place to another, there is a chances of movement of invasive species from its original place to a new place. So through this, which your entire ecosystem will get collapsed. And the sixth one is your impact on marine infrastructures. So this thing will not only happen in case of marine, in case of reactors also it will happen, through which your membrane will be totally fouled, and due to which the performance of the instrument is also reduced. And the seventh thing is your environment impact. Since the fuel consumption is very, very high, obviously it will release your gases, right? Carbon monoxide, carbon dioxide gases will be released, which in turn will increase the greenhouse gases, obviously leading to kind of a pollution. So these are the advantages of biofouling. So then coming on to anti-fouling. So anti-fouling is a vice versa of biofouling. So biofouling is nothing but accumulations of organisms, like it may be your microorganisms or macroorganisms on the surface. So antifouling is vice versa. So we have to eradicate or reduce this biofouling accumulations on the surfaces. So the term antifouling refers to materials or coatings that can be designed to prevent this undesirable accumulations of organisms or to reduce such kind of attachments. So there are three methods of antifouling. One is your physical methods, another one is your chemical methods, and third one is your biological methods. So physical methods is like you will be modifying the surface or you will be eradicating the foulers manually using instruments, and then using radiations and electrolysis you will be going for physical methods. But the disadvantages of this physical methods is like more manpower is required for this, and the instrument cost is also very high. Since it is not cost effective, you will be moving on to the chemical methods. So when moving on to the chemical methods, you will be dealing with self-polishing copolymers, foul releasing coatings, and chlorination kind of things, and organotin, which is nothing but your TBT, tributyl tin is involved. So, but the drawback in chemical methods is, since the chemicals are involved in this method, there is a chance of release of toxicants which may affect your marine environment. So in order to move on from this disadvantages from physical to chemical methods, we will be moving on to the biological methods. So where we will be utilizing your natural products which is available in your marine environment or from ocean or land, to utilize it as an antifouling agents or any enzyme oriented coatings. So these are the three different methods in antifouling. And moving on to the history of antifouling coatings. So initially it is started in 1500 to 300 BCs, where they developed the ship using metals like lead and copper sheets on wooden vessels to reduce kind of fouling. So when moving on to 1800 to 1900, heavy metals were used in a coatings kind of things such as copper, arsenic and mercuries were incorporated into the coatings. In 1800 to till present, copper were used as a major coatings for antifouling preventions. In 1960s, so there was a chemical compound called as a tributyl tin, which was in a high peak for a high peak effective antifouling agent, which is used. And in 1974, there was some problems due to this usage of TBT, like oyster farmers reports an abnormal shell growth in the cluster oysters. So in 1980s, there was a major impact of this usage of TBT, so which created imposex in snails and abnormal development was found in marine organisms. So in 1987 to 2008, this TBT was in boom, but due to the impacts of this, negative impacts of this, they started to find out the toxicity effect, and in 2008, they banned this TBT by using IMO, International Maritime Organization, in 2008. So in later 2007s, alternatives for this TBT or chemical compounds were emerged, like they found an environmental or eco-friendly alternative antifouling coatings, and majorly they focused on copper release regulation. Regulations were also introduced. So after 2008, an eco-friendly based antifouling coatings were now developed, like nano-based coatings, foul release coatings, biomimetic coatings, and natural compounds were also developed. So the present and future studies all focuses on a non-toxic coatings, which will be like eco-friendly one. So this is about your history of antifouling coatings. And in this image, you can see that the first one is the in the image which was taken in 1980s or 1900s. So where they used manual instrument to clean all the foulers in the ship hull. So the down image is nothing but your antifouling paint. So they are spraying all the antifouling paint on the ship hull, and after which they will be sailing the ship in the oceans. And so since I said no, TBT is a very effective one. So after the use of TBT, within a few hours, all the foulers will have been removed from this ship hull. That is a third image. And so I said that in 2008, IMO signed that TBT should be banned for the usage. So the major toxicity studies and impacts which created in marine life is, it causes an imposex in gastropods. So imposex is nothing but your female gastropods have developed an male genital hormones, and the second one is your abnormal shell development. So where the shell formations have been deformed due to this TBT conceptions, and algal phytoplanktons are prone to toxic effects. And there is also an effect on marine invertebrates, and fish also have been seen with the different oxidative stress, liver damage and endocrine damage we see, and the mammals were also affected due to this TBT. So here in this mechanism you can see, so the TBT which has been coated in the ship has been slightly released from the coatings, and it gets leached into the seawater, and this seawater which is consumed by the marine organisms which is living in the sea, it got accumulated in the tissues and it brought to all this kind of issues. So here, these are the two studies which has been studied with the gastropods. So first one is your hexaplex gastropod, where you can see the male genital development organ in this B diagram. So the female organisms is developing a male genital organisms. Similarly, in this dog whelk gastropod also, you can see your male genital organisms. For example, in this case, so this is a normal male organisms which has penis and vas difference, and this is your normal female organisms with a genital opening and there is no vas difference. But in case of an imposex female organisms, there is a development of penis and vas difference. So this kind of imposex is mainly due to the TBT implementations in the gastropods. So in order to avoid all these kinds of chemical related toxicants which causes an ecological damage in the environment, we are moving on to an environmental friendly antifouling coatings. So for which we are focusing on micro nanostructured surfaces, antimicrobial peptide modified surfaces, photocatalytic antifouling matrices, and natural antifouling agent, and hydrogel antifouling material. We will see one by one what will be the mechanism for each and every antifouling techniques. So moving on to this biomimetic or micro nanostructured surfaces. So by nature, lotus leaf, you might have seen that it causes like it is having an hydrophobic property through which the water droplet will not stick onto the lotus leaf. So scientists, by seeing this mechanism, what they tried is they tried to mimic the surface properties in the coatings, whatever and all they are developing. So this is the first image you can see, right? So it is a lotus leaf imprinted with ridges and grooves. And the second one is the biomimetic, like they have developed the similar lotus-like surface, and they have studied through SEM images and contact angle, where they found a higher hydrophobic contact angle was found in the surface. And the third one is the salvia. So that is a fern aquatic plant. So it is also having a hydrophobic nature. And so the SEM images were given here, and it also have a higher hydrophobic water contact angle. Which is developed here. So in this, you can see in this mechanism where, so consider this as a shark skin mold. So they are creating a mold using this pattern, and they will be pouring any kind of polymers can be used as an antifouling agent. Either it may be your PDMS or polyaniline. So for PDMS is nothing but polydimethylsiloxane and polyaniline. Any kind of polymers can be used for this. So what they are doing is, in the mold A, they are pouring PDMS as a shield, and they are curing, and after demolding, again they will be pouring a second set of PDMS, and they will be allowed for curing. So this will replica the shark skin material. So this is not only a replica for shark skin, you can use this for any kind of hydrophobic related marine mammals like a shark, whale, and lotus leaves also you can use as a imprint for the biomimetic structures. So through which your microstructures and nanostructures from those will be replica or mimicked here. Okay. And then moving on to your antimicrobial peptide based antifouling. So here, so you will be using your antimicrobial peptide. Peptide is nothing but your protein which consists of an amino acids. Amino acids are linked together to form a protein. So in this case, so this is your antimicrobial peptide which has arginine, lysine and histidine, which has a positive charges, positive charged peptide groups, which is nothing but positively charged amino acids. So what it will do, this is a bacterial membrane which forms a biofilm. This surface reaction, since it has having a positive charge, it will attach to the negatively charged phospholipid bilayer which has an PO432 minus, and it will damage this membrane, and it will create a cell membrane damage through which the cell will leak and all the entire biofilm mechanism will be collapsed, and it will stop the fouling or biofilm formations. So apart from this, it is having another three more phenomena like hydrophobicity is there, secondary structure formation is there, amphipathicity is there. So hydrophobicity is nothing but this antimicrobial peptides have both hydrophobic peptides or amino acids in it. through which it will bind to the membrane and it will collapse the entire membrane, bacterial membrane channel, through which it will block the cell growth. So the secondary structure is nothing but this antimicrobial peptides will have different shapes of structures in it, like it will have an alpha helix or beta sheet structures. So these structures will collide with this membrane, the phospholipid bilayer, and it will the stable phospholipid bilayer will now be eradicated and it will break the membrane and causing the leakage of the cells, through which your cell death will happen. And this amphipathicity is nothing but your antimicrobial peptide will have both its hydrophobic amino acids and hydrophilic amino acids, through which it will create a shell-like structures and it will mold your cell, through which your cell cannot develop further. So these are the four mechanisms or surface parameters which is involving in your antimicrobial peptide based antifouling. And moving on to the third method, it is photocatalytic antifouling surface. So here the substrate, which is nothing but your considered as your ship hull or material. So and these white color thing are your titanium oxide coatings. So this titanium oxide coating is nothing but your photocatalyst. Since it is a photocatalyst, it will be triggered only upon your light radiations. So consider UV light is passed on this titanium oxide. Now it gets activated. So once this titanium oxide nanomaterial or any kind of coating is getting activated, all the elements which are present in the ground state will now move on to the upper state. So when it is moving from a ground state to an upper state, there will be creating an valency. So this valence electrons will react with the water which is present in the surface of the substrate, and it will create an hydroxyl groups, which is nothing but your OH minus and H2O or O2 minus groups. These are nothing but your reactive oxygen species. This ROS groups will damage the cell membranes and it will damage the protein formations. It will even damage your DNA and it will completely degrade the EPS, by which it is preventing the biofilm formations or the microorganisms to attach. So this is the mechanism of this photocatalytic antifouling surfaces. And moving on to the fourth one, it is an hydrogel and amphiphilic antifouling coatings. So here you will be creating an hydrogel mixtures, for which you will be using monomers and cross linkers with a photo initiator and any kind of nanoparticles you can correlate. So with this you will create an hydrogel mixture. So this hydrogel mixture will have an high moisture content. So sometimes high moisture, if area with a high moisture content, there is a chance of bacterial attachment limitations. So this will also trigger only upon an UV light radiations. So when this mixture is coated onto the substrate, obviously there will be an antifouling mechanism will happen, and this polymers, this hydrogel mixture will have an both hydrophobic and hydrophilic reaction groups, through which it will prevent the attachment of organisms to the substrate. So this is about your hydrogel and amphiphilic antifouling coatings. And moving on to the fifth one, it is a natural products as an antifouling agents. So as I said, no, like physical methods, chemical methods, since it have these many drawbacks, natural products is a good source for an antifouling agents, which may be less toxic to the environment or other non-targeted organisms. So for which you can use marine. In case of a marine source, you can use for marine algae, marine invertebrates, marine bacteria, and marine plants. So what we will be doing, like we can take any kind of marine source animals or algae or bacteria. So you can extract metabolites from them in so like alkaloids, terpenoids, phenols. So any kind of metabolites you can extract from them. This metabolites can be used as a coating material in along with the polymers or nanoformulations, and it will target the cell membrane, and it will eradicate the DNA synthesis, and it will totally eradicate your membrane formations itself. So how it is how the major mechanism of actions for this natural antifouling is, so initially it will prevent your antibacterial activity by membrane damage, and it will also stop the anti-biofilm, it will stop the biofilm formations, like initial adhesion and EPS secretion will also be stopped in the initial stage itself, and quorum sensing inhibitions. So there are two parameters like which we have to know is, one will is your quorum sensing, another one is your quorum quenching. So quorum sensing is nothing but once your substrate is immersed in surface like for in a water surface for a long period of time, I said there will be an EPS accretions. So due to this EPS accretions, there will be attachment of a single cell. So after which there will be a cell to cell communication, so that another bacterial cell will come and attach, and this chain continues on. So this cell to cell communication is called as a quorum sensing. So this quorum sensing inhibition will be triggered by this antifouling agents. So in case of quorum quenching is nothing but if you are trying to stop this quorum sensing mechanism, the cell to cell communication, that process is called as an quorum quenching. So then moving on to the fourth part, it is anti-algal and anti-diatom. So once bacterial inhibition is done, so if not bacterial inhibition is done, then we have to target for anti-algal and anti-diatom activity, and after which it will also target an anti-larval settlement inhibitions through ROO secretions and enzyme inhibitions. So this is about your natural products. Not only on marine algal derived antifouling agents, you can choose terrestrial plants which is available as a wheat plants also for your antifouling agents. So here you can see, right, chili pepper and walnut, sponge, everything you can use it as a extract, and you can create or produce metabolites from them as an antifouling agents. Then so moving on to the nano materials for antifouling applications. So nanotechnology is nowadays developing for antifouling applications. So here you can see as a single metal based nanomaterials also is available for antifouling. So for example, acid, silver, copper, zinc oxide, titanium oxide, iron nanoparticles also is there, and non-metal based nanomaterials like silicon oxide, carbon, graphene is also available for as an anti-biofilm agents. Apart from this, there are polymeric nanomaterials, like as I said, no, PDMS, PEG, polyaniline, all kind of nanomaterials also there. So in case of composite nanomaterials, you can use this nanoparticles and polymer as a colloidal substance, and then you can create a composite. That composite you can use as a coating for the antifouling. So apart from this, you can use all this kind of nanomaterials in marine antifouling. And there is something called as a medical biofilms. This biofilm is not a problem for marine alone. It is a major problem in the medical field also, where the catheters will develop in biofilms. So in such kind of medical biofilms also, nanoparticles have been widely used for anti-biofilm eradications. So carbon dots and dendrimers are developing nanomaterials for an antifouling applications. And moving on to the 3D printing for advanced antifouling surfaces. So this is an advantage, like recent advanced methods that is used for an antifouling surfaces. So what you will do, like here you will be having your sharp surface. So you will be creating a CAD model using a software, and you will convert the image into an STL file, and then you will be slicing the image into different layers. So that layers will be printed using your 3D printers, and finally you will get your 3D printed object. So there are different methods of 3D printing formulations. So for example, electrowriting is there, and fused deposition modeling is there, and material jetting is there, and digital light processing is there. So in case of electrowriting, what we will do, what it will happen is, right, so high electrical impulse will be given for the polymers, and through this nozzle and the high electrical impulse, the polymers will be drawn as a separate layers, and your final substrate will be ready now. In fused deposition modeling, a thermoplastic material will be there, so which will be melted, and that molten metal will be again imprinted on the substrate as a layers, and then finally your 3D printed material will be ready. So material jetting is nothing but your like inkjet printing, like a normal paper printing thing. So where the polymer will be casted onto the substrate, and finally your polymer substrate will be ready for the user. And in case of digital light processing, it is similar to kind of all the 3D printers. The thing is, it will be activated only in case of a light source like UV kind of light source. So this image shows you that, so from the shark, you can see that there is a ridges and grooves like dendrimers is present here, and through which you will be developing image in the software using, as I said, no, from CAD model or STL file, you will be developing an image, and through which after printing you will be getting an 3D printed object that mimics your that shark surfaces. So this is a process where your ultraviolet rays will be projecting in, and inside which you will be having your resin material. And since you have already feed this program, no, you will get the exact material which mimics your shark screen in the final printed versions. So these are the contact angle measurements which have been taken for this substrate which is developed finally. Yeah. So this is about your 3D printing, like which is a recent advanced technique which is developing. But the drawback of this technique is like it is very costly. And moving on to the future of anti-fouling techniques. So we have seen about conventional anti-fouling techniques like biocidal paints, so which has copper and it will release toxic compounds, and so we have to take in concern for an environmental things. So currently in industry they are using self-polishing and foul release coatings, so through which your fouling adhesion will be minimized. And in now recently emerging technologies, like as I said, no, nano related coatings and biomimetic coatings and photocatalytic and ROS generated coatings have been developed in emerging technologies. And through in next generation techniques will be like multifunctional properties. So like it has to give both anti-adhesion property, anti-biofilm property, and the coating which you are developing should be durable and it should also be non-toxic. So the future goal it's we should develop coating techniques like it should not be toxic to the environment, and it should also not leach into the marine environment when it is exposed, and it should be a long lasting one, and it should also not target any non-targeted organisms. So what I am concluding here is you cannot completely eradicate the fouling techniques, but you can minimize the fouling mechanism. Like you can increase the period of fouling. So for example, like if you are taking a ship for dry docking in like around 6 to 8 months, if you develop a coating which has a high efficient environment and eco-friendly non-toxic one, like at least it should prolong this dry docking process from at least 6 to 8 months to at least for 9 to 10 months. So from like the thing is you have to prevent the fouling for a maximum duration of time. So the future of anti-fouling lies not in biocides, but it is in a smarter surface development. So thank you.
So
if
thank you
there
so
any
much,
questions
ma'am.
related to the topic, you can ask them.
So thank you so much, ma'am, for the informative and interesting presentation. So participants, if you have any doubts, you can post your questions in the chat box. Ma'am, actually there is a question in the chat box, ma'am.
Yes.
Does all the anti-fouling materials, whether commercially available in the current market,
Does all
the anti-fouling materials, whether commercially available in the market?
Not all anti-fouling materials are available in the market. So before coming to the market, like it has to go through different entry level checks from laboratory exposure, and you have to do for the toxicity studies and leaching studies, and after which only like you have to go for the approval of anti-fouling paints or coatings in the market. So then only you will be applicable to go for a patenting thing. So not all anti-fouling coatings which we are developing will be directly marketed to the industries. So I
thank you,
have
ma'am, for
to, yeah, thank you. I have to clarify one more thing here. So related to anti-fouling coatings, I am working in marine biofouling lab under the guidance of Dr. D. Inbaganan sir. So here we are working on different coating techniques like nano-related coatings, polymer coatings we are developing here. And we are doing all laboratory kind of experiments we are performing in the lab scale itself. And we are doing all kind of toxicity level checking and studies also we are performing here using instruments, and we have all advanced instruments for performing the characterization techniques like AFM, CLSM is there. So once all the preliminary toxicity studies have been performed in our laboratory, we will be moving this nano coatings or polymer coatings to and field exposure studies which we have in JPR Fishing Harbor Muttam. So there we will be exposing all the coatings what we are developing here, and we will be study for 30 days, 60 days, and we will be prolonged for around 6 months also we are during the exposure study. So after which successful development of this coatings, we will be going for patenting. This is what we are working in our lab as a scholars here. Thank you.
Ma'am, there is another question in the chat box, ma'am.
Yes.
Which is commonly used anti-fouling material or agent without harmful to organisms?
So commercially now they are going for self-polishing polymers and foul release coatings at the foul release coating, and in that one thing is called as an C quantum. So that chemical is used as an anti-fouling paint commercially in more numbers in industries.
Okay, ma'am. Thank you, ma'am, for answering the question, and thank you to all the participants for your active participation. Before we conclude, I would also like to inform everyone that I have shared some useful information in the chat box, including consultancy services related COR and NFCMR, MSc Marine Biology admission details, internship opportunity being conducted at COR and NFCMR during August. I request interested participants and students to kindly check the chat box and make use of these opportunities. With this, we conclude today's Ocean Research Knowledge Series session. On behalf of COR and NFCMR, I sincerely thank Ms. Anu for the excellent session and all the participants for joining us today. Thank you, everyone. Have a wonderful day ahead.
Thank you, Taufik.
Thank you.
Thank you all.